All right, let's look at another pair of examples, simplifying trig expressions. And so they're just becoming more and more involved. So here we have to simplify cosine theta plus sine squared theta over cosine theta, all of that over sine theta. Um, there's maybe multiple ways to approach it, but this is the way that I approached it. So from the last example, it would be nice if we could consolidate these two by putting them under a common denominator. So to do that, we need to multiply this term by cosine theta over cosine theta, which is what you're seeing me do here. And now that these two terms have a common denominator, you can see that this would be cosine squared over cosine theta. And then this is, of course, sine squared over cosine theta. So you're going to have cosine squared theta plus sine squared theta all over cosine here. Well, using the Pythagorean identity, which is cosine squared theta plus sine squared theta equaling 1, we can see that this numerator here should be equal to 1. So we get 1 over cosine theta divided by 1 over sine theta. And, to maybe make it so that we're not dealing with a fraction anymore, we can take this sine theta and multiply top and bottom by its reciprocal, like that. And so sine theta will cancel with sine theta. So what we have left is 1 over cosine theta times 1 over sine theta. And cosine theta is secant theta, and 1 over sine theta is cosecant theta. So this original expression here simplifies down to this expression of reciprocal trig functions. All right, so here's another example. Use my previous one as a model. Don't forget to refer to this page of trig identities and see if you can do this next one on your own. If you need some help, come back and resume the video. All right, give it a try. Pause now. Okay, we're back. So we can apply kind of the same idea that we had before. Up here in the numerator, it'd be nice to be able to combine those two terms, but of course you have to have a common denominator between them. So we're going to have to multiply this expression by sine squared theta over sine squared theta. All right, so let's go ahead and do that. So we're going to write all this out. Cosine to the fourth over sine squared theta plus cosine squared theta. And that's going to be times sine squared theta over sine squared theta. Oops. Okay. So, oh yeah. This hasn't changed. All right, so here in the numerator, we have a common denominator. So now I'm going to go ahead and combine those. Now, I do have room going down. Yeah. Let me go ahead and go down for now. Okay, so let's consolidate. So we've got cosine to the fourth theta plus cosine squared theta times sine squared theta all over sine squared theta all over cosine squared theta over sine squared theta. Okay, so with a compound fraction like this, it can be difficult to keep things straight. But one thing you should notice is that we have a sine squared theta in the denominator here, and in the numerator of this compound fraction, we also have sine squared theta in the denominator there. So if we have a sine squared theta in both denominators of this compound fraction, they will cancel out. And what that will do is that'll leave us with cosine to the fourth theta plus cosine squared theta sine squared theta all over cosine squared theta, like that. So you can see this denominator of sine squared theta is gone from both the numerator and denominator of our compound fraction. All right, now it would be nice if we could maybe get rid of this cosine squared theta, and we have one of those here in this term in the expression in the numerator, but we need to have a cosine squared theta in the other term in the numerator as well in order to be able to cancel out properly. So let's change this cosine to the fourth. We can write that as cosine squared theta times cosine squared theta, just like that. And what that'll let us do is we'll be able to finally cancel this cosine squared theta with one of these and one of those. And that leaves us with just this. So we'll be left with cosine squared theta plus sine squared theta. And guess what? That's equal to 1. So this original, very messy looking trig expression, all of that simplifies down to just 1. Aren't these fun? Yeah. My friends and I, when I was taking trigonometry in a summer class, we really banged our heads on walls for a while, trying to, figure these out. It's a lot of trial and error, and going back to the trig identities, trying one, not working, trying one in here, it doesn't work. Come back, try a different one, plug it in, doesn't work, until finally you kind of find the right key that unlocks the simplification, and then suddenly it just goes from this down to that, and you've got it. So take some time to learn and to figure out. Okay, let me know if you have any questions.